Well, hello, everyone. I'd like to welcome you to this session on Playful Features. My name is Kevin, and I'm excited to talk about features. I'm hoping to relay that excitement to you as well. Before we get started, I thought I would give you a little bit of my background. I'm a father and a grandfather. My wife and I have a son and a daughter and 4 grandchildren. So you can imagine that we enjoy traveling and playing with grandkids. I also cycle just a bit, and I very much enjoy college football. Well, you can see that I've been involved in the software industry for over 40 years. My wife and I actually began our careers together back in the 70s, believe it or not. She also has a computer science degree, and we began our work at General Motors. In the 80s, we moved to the St. Louis area, and I started work at McDonnell Douglas Aerospace Company. And in the 90s, I started consulting. And so I've worked for a number of different companies in the St. Louis area. I actually retired in 2015, and that's when I started working with and contributing to open source. Well, there's one common theme on this slide if you haven't yet noticed, and that is I'm probably the old guy in the room. And just to prove it, this is what computers looked like when I first started my career. So I like to say that I'm a current developer from a different era, and I do try to stay current as much as possible, but I think we can all agree that that's getting harder and harder to accomplish at the rate that technology is advancing these days. Well, we're here to talk about feature-based development that plugs and plays. That was the inspiration for the Playful Features title. And specifically, we're going to be looking at a utility called FeatureU, which facilitates this process for the React platform. Now, I should mention that even though this is a React utility, the dependency on React is fairly minimal. And so I could see in a future release where that was relaxed and opened up just a bit. But certainly the concepts that we're going to be talking about are applicable to any platform, to any framework, to any language for that matter. Let's take a quick look at the resource link that's highlighted in yellow here. You may have noticed it on previous slides. I've also highlighted this in my demo page in the upper right if you missed it. It's a bit.ly link. It's feature-u-pres, P-R-E-S. This is a link into my webpage, and if you click on the presentation button, it'll scroll down and you can find a number of resources that you can look at your leisure, some articles, plugins, repos, etc. The items that we're going to be focused on today are highlighted in yellow. There's a copy of the slides if you want to follow along. There's a link to the FeatureU documentation. And probably the most important link is the third highlight. Eatery-nod is a progressive web app that's actually implemented using FeatureU. And so we're going to be looking at that as we get into some code snippets later on in the presentation. So while we're here, let's go ahead and take a look at the docs. If you just click on the FeatureU docs link, FeatureU is well documented. There are a number of sections in the user guide that builds concepts and shows you code snippets, etc. And of course, the main part of any documentation is the API, and this is the core API from FeatureU. There's really only a handful of functions that make up the utility. If you link into one of the items, not only will you see the details of that given function, but you're also going to find linkages into the user guide that gives you additional context for that particular function. FeatureU is extendable, and there's an entire section on extending FeatureU. You're typically not going to need to get involved with this. Hopefully you can find a plugin extension point already pre-packaged in NPM, but it's available for your use should you need it. Okay, let's go ahead and get started. We've already talked about the documentation. So I don't know about you, but the first thing that I think about when I think about feature-based development is your project directory structure. As a general rule, you have a choice. You can organize your code by what it is, and that would be a type organization, or you can organize it by what it accomplishes, and that would be a feature-based organization. So within the type organization, you're going to organize your code based on some type classification. So it's not uncommon to find directories that contain all of your UI components, your routes, your business logic, state management, etc. Now, on the feature-based side, it's going to be organized by features or requirements. So within a given feature directory, you're going to find all the modules that implement that feature regardless of their type. So all projects have features. The question is the code that makes up a given feature, is that nicely organized in a single directory? Or is it going to be scattered all across your code base as it would be in the type structure? So within the type structure, it's also very common to find a directory that's related to the bootstrap startup of your application. And this could be both app-specific initialization code as well as framework configuration. Now, within the feature structure, we would like to encapsulate that initialization code in the features that require it. Now, that's going to be a little more difficult to do without some help. So we'll be talking about that very, very shortly. So in general, I think the consensus is that a feature-based structure is going to scale better simply because there is that direct correlation between your requirements and the implementation. Well, the directory structure is a good starting point, but there are a number of goals that we would like to accomplish over and above this. For example, we would like our features to be requirements-based. This is really a design constraint, and so it's pretty much up to you to implement. But that's what makes feature-based development intuitive from a code perspective. We'd also like our features to be encapsulated and isolated. And to the extent possible, we would like our features to be self-reliant or self-sufficient. If we do this right, the mere existence of a feature is going to exude the characteristics that it implements. In other words, it's going to plug and play. We'll be talking a lot about this throughout the presentation. Well, as it turns out, there are a number of hurdles that we need to overcome in order to accomplish these goals. As an example, how do we reconcile the fact that we want our features to be isolated, and yet we know they need to collaborate with one another in some fashion? As I mentioned earlier, we'd like to encapsulate the startup initialization within a feature, the various features that require it. Framework configuration is something that's potentially going to be more difficult because now we've scattered the aspects that need to feed into this configuration across all of our features. UI composition is something that is not uncommon to cross feature boundaries. So how do we manage that? We'd like to be able to enable and disable features, even though they're part of our code base for a variety of different reasons. So in short, how do we achieve a running application from these set of isolated features? That's the big question. Well, as it turns out, there are two primary characteristics that are needed in order to achieve these goals. And those items are number one, feature runtime consolidation, and number two, feature collaboration. Now, these are my terms, but they pretty much form the basis of what makes feature development work. And so it's pretty important to understand. Let's take a look at each one of these. First of all, feature runtime consolidation. This is really dealing with the startup initialization of your project. And it can really be broken down into two subcategories. The first one is app-specific initialization that's required by each feature. It could be that one feature needs a database connection, or another feature may need to even inject some DOM into the static root of your project. The second subcategory is framework configuration. Now that we've organized our code in frameworks, we've organized our code into features, the framework configuration can be a little more difficult because we need to pull in aspects across all these features to feed into the framework configuration. The second major tenet that I mentioned is feature collaboration. We've already talked about the fact that we want our features to be isolated, and yet we know that a feature exists as part of an overall larger application. So there's going to be some requirements to collaborate with other features. And this could be just generalized, feature sharing across the feature boundaries, as well as UI composition that crosses feature boundaries. So you may be thinking, well, that's not an issue. I can simply import these resources that I need. And that is something that's tempting because it's simply a directory import away. However, this is something that I would consider an anti-pattern. As a general rule, I don't believe that your imports should cross feature boundaries, for the simple reason that we want this to be some type of more public, formal API. Just to take a simple example, let's say the F1 feature imports a resource from F2. Well, that's going to work initially, but if you think about it, it doesn't take into consideration some very basic characteristics, such as, is the F2 feature even enabled? In which case, if it's not, that resource is not available to you. Well, that's one example that we can highlight, and we can come up with some more as well. But in general, if we throw out this concept of cross-feature import, the question remains, how is cross-feature communication achieved in such a way that doesn't break encapsulation? Well, these items form the basis of why Feature U was created. When it comes to this topic, there are a lot of good articles out there, but in terms of the implementation, you're pretty much left to fend for yourself. So that's why I started thinking in terms of a utility library to see if it could facilitate this process. So here's the bottom line of what we are trying to achieve. If we can modularize our application into features that are requirements-based and encapsulate our startup initialization within the feature that requires it, and support a runtime enablement and disablement of our features, and most importantly, if we can provide a mechanism for cross-feature collaboration in an extendable way, then we can achieve our ultimate goal of plug and play, where the mere existence of a feature exudes the characteristics that it implements. Well, what this really means is we have structured our application into a series of miniature applications where our features are loosely coupled, improving their modularity and making our overall application easier to understand, to develop, test, and refactor. So this is similar to how microservices achieve a very similar goal. So at first glance, this may seem like an overwhelming task. However, it's really not with the right approach. You can actually achieve these items today with Feature U, and it's not that hard. Okay, we're going to be covering quite a bit in this session. We're going to look at how our application startup process can be simplified. We're going to look at our feature enablement and disablement. We're going to be spending quite a bit of time on cross-feature collaboration. And we're also going to briefly look at A/B feature swap, something that's very common within the feature-based development realm. Now, all these items we're going to be looking at in the context of our overall overriding goal, and that is how can we achieve this plug and play. Okay, to make sense of this, we're going to be looking at a real application that uses Feature U. I'm going to give you a quick orientation to the app to familiarize yourself with its features. Eatery-nod is a web app that randomly selects a restaurant from a pool of favorites. So my wife and I have a steady date night with another couple, and we're always indecisive about which of our favorite restaurants we wish to frequent. And so basically, eatery-nod provides the spinning wheel. In other words, it gives a nod to an eatery. Well, my wife and friends aren't really enamored with the name, but I tell them that geeks have to have fun somehow, and naming stuff is one way to do that. So here is the eatery-nod app. It does require an authentication. And this authentication is backed by the Firebase cloud service, if you're familiar with that. So once you're logged in, your ID is assigned a pool of favorite restaurants that you can maintain persistently. That persistent pool is actually maintained again by Firebase real-time database service. And so you can see that I've named my favorites date night, and here's all of our favorite date night restaurants. So the main function of this is the spin button on the bottom. If you spin, it'll randomly select from 64 entries. And here's our restaurant for this particular Friday night date night. So if you don't like this item, you can cheat and spin again. So there's a second selection. You can do things like, let's say you want to filter this pool. Let's say you're tired. You don't want to travel very far, so I'm going to limit it to 3 miles. And I'll go ahead and sort it by distance. And so now if I spin, it's spinning from the filtered list. You can see it's 21 entries instead of the 64 entries. And from here, you can actually interact directly with these items. So you can bring up navigation, you can phone the restaurant, you can bring up their website if you want to look at their menu, etc. So how do you maintain this information? There's quite a bit of detail in each restaurant. You don't have to maintain it by hand. There is a second view in eatery-nod, and that's the discovery view. So basically, discovery does a geographical search for restaurants within close proximity of the device. And this is actually backed by Google Places API, if you're familiar with that. So it's very similar to actually doing a real Google search. The only difference is we maintain whether or not this restaurant is in your pool of favorites. And if it is, it'll have the red check by it. And that check is actually a toggle. So if I want to add, for example, Jimmy John's to our pool of favorites, I simply toggle that and it turns red. And if we go back to the pool, we should find Jimmy John's, and there it is. So all this information was added from the Google Places data store. So there's a lot of features that you get sort of for free with some common features on the app that are implemented in an app neutral way. All the menu items on the user menu, here's a theme of dark and light. You can bring up an about dialog, and that shows you description and version, documentation and history. This information is actually pulled out of your package.json, which allows the feature to be implemented in an app neutral way. The system is responsive. If you'll notice, within a cell phone set of real estate, the detailed screen takes up the entire device. But if you have a little more real estate, that turns into an actual dialog box. And if you have even more real estate, then that simple list morphs into a table, and you can interact with each individual item directly from this list rather than going into the detail screen. So that's eatery-nod in the nutshell. Let's take a quick look at the source, just a brief view, initial view here. So from the resource page, if you click on the eatery-nod link, you'll go into the GitHub repo for eatery-nod. And there's a lot of good documentation here as well in the form of README files. And those README files are scattered throughout the source tree. So for example, I want to bring up the features directory in the source. This is where all of our features are packaged. And you'll see here that it also has a README file, and that basically shows you a short description of each one of the features. I think you can already recognize the features, the eateries features. You can probably imagine what that's doing, discovery feature. Here's our set of common features that I mentioned. There's a base UI feature that provides a UI foundation for all of our screens. Authorization is app neutral because of the Firebase service. Here's a GPS location service that maintains our location within our application state. A couple of diagnostics, etc., etc. Let's drill into one of these features. if I click on the eateries, you'll also find a README here that shows you the screen flow and state transition diagrams for documentation. Let me back up into the root of the eatery source. And so here are all the modules that make up this particular feature. Now, the one thing I want to look at right here is the feature.js module. This is basically, as we will see shortly, all features promote a feature object. So here's a create feature that's being exported. That's a feature U function. It's got a name and a variety of different aspects that we'll talk about briefly in just a moment. All right, well, that's eatery-nod in the nutshell. What I'd like to do is give you a sneak peek at some things that you can accomplish with Feature U. This is more of a teaser that will hopefully spark your interest before we get into some of the details. So the first one I'd like to look at is the application startup process. All developers complain about the amount of bootstrap code that's required to initialize their application. I don't know if you've ever played this game with one of your colleagues. I can write that function in X lines of code. Well, what if I told you that I can implement, or I can actually start your application up and running with a single line of executable code? And that was true regardless of how complex your application was. And it includes both app-specific initialization as well as framework configuration. Well, I can hear the murmuring now. You're saying this guy's gone over to the dark side into the marketing department, and he's really blowing smoke. Well, while this may be a bit of an exaggeration, there is in fact a single line of executable code that makes up your main line. So let's take a look at that. I'm going to bring up the actual source code in my editor. And so here we are in the eatery-nod source. If I open up the source tree, at the root of the source is the app.js file. And this is the mainline startup process. And as you can see, it is a single line of executable code. LaunchApp is a function from Feature U. You give it a set of features and a couple of callback functions, and you're pretty much done. So just as a way of a little bit of a background here, what's really happening under the covers is we have encapsulated the app-specific initialization within the features themselves. And so LaunchApp, given the set of features, can interact with those features to do the startup process. So we're going to be looking at this in more detail in just a moment. Well, the second teaser that I'd like to look at is the plug and play goal. And this is where the mere existence of a feature can exude the characteristics that it implements. Now, this can be either physical or logical. We would like a way to be able to enable or disable a feature. So what if I told you that you could actually disable a feature and all of the characteristics that it was providing would actually be dynamically removed? Let's take a look at that. Let's say, for example, within the eatery-nod application, we want to reserve the discovery view for users that have actually paid for its use. So if you're a licensed subscriber to the app, well, it'll give you the discovery view. Otherwise, you'll be forced to maintain your restaurant information by hand. Well, this can actually be done very easily. If we expand the features and look at the discovery view, let's bring up its feature object. So there is an enablement property on the feature object, and all we have to do is resolve that to a false for it to be disabled. So I'm going to say enabled is false. Now, normally you wouldn't hard code this. You want this to really be a runtime expression because you want it to change over time. But in this particular case, I haven't architected that, so I'm just going to disable it to show you what will happen here. So if I save that, the system will rebuild. And once it's back up and running, you can see that we no longer have access to the discovery view. It's actually been dynamically removed. I should mention that there is no conditional logic within my application that's making this happen. It's merely the fact that we have disabled this feature so it no longer exists. So we're going to see how that is actually working as we get into our presentation a little closer. Okay, the last item I'd like to look at from a teaser perspective is the A/B feature swap. This is something that's very common need in feature-based development. You may want to swap out one feature for another for a variety of reasons. So in this teaser, we're going to look at how we can actually use this to drive our mock services. So this is a very common example. In the development mode, you may want to swap out a real service with a mock service that we can interact with in various use cases that are canned, so to speak, within the mock. So within feature U, again, within the source root, right next to the app.js, there's a features flag. And one of the flags on here is use Wi-Fi. You can see in the documentation it says that this item regulates whether or not we're using real or mocked services. So if I turn that off, system will rebuild. And we're now actually using mock services across the board. You can see we've logged in as the mock guy. Our pool is called mock, and all of our restaurants are coming from New Orleans from basically an in-memory database within our mock. Now, we haven't actually seen how this is accomplished. We need to learn a couple of constructs here. Basically, the bottom line is that these services are actually promoted through features, and so the enablement and disablement of the features will actually wire this up within feature U. So we're going to look at that in more detail as we get further into the presentation. Okay, well, hopefully I've piqued your interest. So let's dig into feature U just a bit. So as we have already seen, one of the most rudimentary functions of feature U is the launchApp function. LaunchApp is an agent that works on your behalf, and it actually starts your application up and running. And it does that with a very minimal amount of input. The primary input to LaunchApp is a set of feature objects. And these objects are merely a lightweight catalog of aspects that are of interest in starting up your application. So let's take a closer look at this. Within a feature, it's going to contain a number of aspects that actually implement that feature. And for the most part, that's considered a private implementation detail. But some of these items are of interest in starting your application up and running. And that's where the feature object comes into play. So you can see here I've color-coded the properties of the feature object. The red items are built in, and the green items are extension points. So in general, you can see that all features have a name. It looks like they can be enabled or disabled. Fassets is feature assets. We'll talk about that in just a moment. It's basically the public API of your feature. So it looks like this feature is maintaining some application state. So it's registering a feature-based slice of our overall application state to a framework. It's also registering some logic modules. Evidently, we're using some framework that's allowing us to model our business logic in separate modules. And this last one, app will start, it looks like it's some kind of an application lifecycle hook. Well, we're obviously going to be talking about each of these items in more detail. But the takeaway from this slide is that a feature object is merely a lightweight catalog of aspects that are of interest in starting your application up and running. All right, let's look at some solutions. Remember the first item that we talked about, a feature runtime consolidation, and we broke that down into two subcategories of app initialization and framework configuration. Let's see how feature U can accommodate this particular item. So from what we know about feature U so far, we know that launchApp is in control of starting the application up and running. So if you think about it, it's in a very prime spot to introduce application lifecycle hooks. Now these are merely callbacks into the or within your feature that allows it to do whatever type of initialization that it deems fit. And there are 3 in total. And I've color-coded them here so you can find them more readily. The first item is app will start, and it's color-coded in yellow. Now this one is invoked very early in the startup process, and you can really do any kind of initialization that you deem fit. But the key takeaway from this one is it allows you to inject DOM into the static root of your project by simply returning a new root app element from the return value. So you can see here that the F2 feature has a yellow app will start registered as well as the F3 feature. So very early on in the process, launchApp is going to call out to the F2 and the F3 to do whatever initialization they deem fit. So the second hook is app init, and it's color-coded in blue. Now this one's invoked later in the app startup process. And just like the first one, it can really do any kind of initialization you deem fit. The key takeaway from this one is it supports blocking asynchronous initialization. So by simply returning a promise, then basically feature U is going to block and wait until that function completes successfully. So you can see here that the F1 has an app init registered along with the F2. And so later in the process, launchApp is going to call out to these features to do their initialization. The last item is app did start, and it's color-coded in green. Now this one's invoked immediately after the app is up and running. And it basically, as a result, can be used to trigger some type of app is running process. Maybe you have an authentication that needs to kick off at the very beginning of the startup of your application. And the app needs to be up and running because that particular process may need to display some sign-in screens to gather information, etc. So you can see here that only the F3 has a green app did start. So very much at the end of launchApp's lifecycle, it's going to call out to the F3 to do its initialization, and then pretty much launchApp is done. Your application is now up and running, fully initialized. So this is really cool because now for the first time, we've encapsulated our app-specific startup initialization within the feature that requires it. Okay, the second subtenet of feature runtime consolidation was, remember, framework configuration. This was a major goal from the very beginning because I knew that it was going to be potentially more difficult to initialize frameworks within the feature-based organization because we've scattered out aspects that are needed by the framework across all of our features. So how can this be accomplished when there are so many different frameworks out there and no 2 projects are going to be using the same set of frameworks? Well, the obvious answer to that is that feature U is extendable. So the extension point for feature U is the aspect object, capital A aspect, and I've color-coded those green in this diagram. So you can see that launchApp actually accepts 2 major inputs. It accepts features and it accepts aspects. So the basic goal of an aspect is to gather up information that it needs across all the features and then run some kind of a global process that's exposed in some way, such as a framework that's fully configured. So you can actually create an aspect with the create aspect feature U function. But again, typically you're not going to need that because hopefully you can find this plugin aspect already prepackaged in NPM. This one happens to be a feature-redux package. And basically it's an integration between the Redux State Manager and feature U. So you can see here that the name of this aspect is reducer. That actually extends the feature object to allow reducer properties. So in essence, any feature that's maintaining state will register a reducer. and that would be a feature-based slice of the overall application state. So in essence, what this is going to do, this aspect is going to gather up all the feature-based reducers, combine them together in the overall application state, and then fully configure Redux for your use. And it does that through a series of aspect lifecycle hooks, where launchApp is calling out into these aspects. That's very similar to what we just did with the application lifecycle hooks within the feature itself. But they're a different set of hooks for the aspect. We won't get into the details of that. You can see here that I've also registered a second aspect. This is a feature-redux.logic package. Redux-logic is a middleware extension of Redux that allows you to model your business logic within separate modules. It's basically a middleware extension point to Redux, a very popular framework, and it greatly simplifies your code. I would highly recommend that you take a look at that if you're using the Redux package. So now we've actually encapsulated all of the framework configuration within these extendable plugin objects. So you're not going to find anywhere within our application code the framework configuration. It's pretty cool. So let's see how this operates within the eatery-nod. We'll look just a little more detail at our startup process. We already looked at the mainline app.js. And so we can see here that launchApp is accepting a set of features and a set of aspects, as well as some callback hooks. So where's the features coming from? Well, if you notice here, we're importing all of our features from the features directory. So if we expand the features directory, you'll notice not only does this contain all of our features packaged together, but it also has an index.js file. So this is basically simply importing the features from wherever they reside and publicly promoting them through an export default of an array. So in essence, these features is merely a flat list of feature objects. So the same thing is true with aspects. You'll see the aspects directory here, and it has an index file as well. The main difference here is it's pulling in these aspects from separate NPM packages, but it's ultimately simply just exporting them as a default array. So the aspects are merely a flat array of aspect objects. Now this aspect directory would also provide a location for a local aspect should you need to create one within your project, say if you can't find it in NPM. So really, where did all the complexity go here? Well, we know the aspects are actually doing all of our framework configuration, and that's now external to our application code. But in terms of the app-specific code, we need to look at all the different application lifecycle hooks within the features. So let's do a search in our project. And remember, the first one was app will start. And it looks like there's only one here. And so if you look at the breadcrumb here, this is in the base UI feature, and its app will start is actually injecting this main layout component into the static root of our project. So this is how that's done. It's an accumulative process. You're given the current root app element, and that must be contained in anything new that you return. And so basically any downstream process of additional app will starts would be given now this main layout component as the current root app element parameter. So that's the accumulative process. So the second callback, if you remember, was app init. And there's a number of those. Let's just look at one of them. Again, if you look at the breadcrumb, this is the GPS location feature. And its app init is actually getting the current GPS location, and it's taking that location and maintaining it in our app state by dispatching a Redux action to do that. You'll notice here that this get current position is an asynchronous function. So we're actually using the async await syntax here. And so in essence, that means that this function is returning a promise. So feature U is going to block until this promise completes successfully. If you'll notice here, I've got a diagnostic that's currently off that's going to inject an additional artificial 3-second delay. Let's turn that on and see what it looks like. So the system will rebuild. And you can see here it's initializing GPS location. So feature U is actually blocking for this initialization to complete. The last callback, if you remember, was app did start. And if there's only one of those, and from the breadcrumb, you can see this is the authorization feature. And so its app did start is actually kickstarting an authorization process. We talked about that earlier. So this guy is going to probably look to see if you've got some stored credentials, in which case it'll automatically log you in. Otherwise, it will display some sign-in screens and gather that information that it needs appropriately. All right, I might mention that one of the callbacks we didn't talk about is register root app element, callback into launchApp. Basically, once feature U accumulates its entire static root DOM, it's calling back into the application domain to do that registration. And we do that for a couple of reasons. If you think about it, this get element by ID, this root ID is app specific. Feature U doesn't know where you want to put this item. But more importantly, feature U doesn't really even know which of the React platforms you're using. This happens to be a web app. So we're using the React DOM.render, but this could equally be a native app. We're using React Native or the Expo library that's a layer on top of React Native. And so you can see basically if you were using one of those other platforms, the registration function would be a different one from that particular framework. So in essence, with that very simple heuristic of calling back out into the application domain, you can see that feature U is compatible with any of the React platforms that are out there. Pretty exciting. So again, now we have completely encapsulated our app startup process through both app initialization of application lifecycle hooks, as well as our extendable plugins that implement our framework configuration. I should mention that this is made possible because feature U is in control of the startup of the application. I think that makes sense after looking at that. All right, let's take a slight excursion and look at feature enablement. Basically, by default, all features are active. But you can actually disable a feature through the enabled feature directive. And we saw that in one of our teasers. So here it is in code sample. Here we are in a sandbox feature. And you can see it's enabled only when we are in the development mode. And this is a more realistic example because the expression is a runtime expression. We want this to change over time. And again, this is made possible because feature U is in control of starting your application up and running. This is one of the simplest implementations internally within feature U. Feature U is given a set of all of the features that make up your application. The very first thing it does is simply prunes that list into an active set of features and uses that going forward. So let's take a look at that in our code. So we do in fact have a, let's close out some of these items. We do in fact have a sandbox feature here. If we go into the common directory, diagnostic directory, here is a sandbox feature. And let's bring up its README file. So basically, this sandbox feature, when it's enabled, it's going to inject a lot of additional menu items in the left nav menu. So let's look at the feature object for that. So here is the enabled property. It's enabling it when feature flag sandbox is defined. So if we load up the feature flags, Here is, in fact, the sandbox. If we enable that, system rebuilds. And sure enough, in the sandbox, we have a whole series of additional developer tools that we might want to do. Basically, here's like what my notify looks like, and you can interact with that. Here's a toast message. Basically, it's just allowing the developer to inject some integration type tests within your application. So we're going to look at this. Let me go ahead and disable this back again. Look at this in more detail, because we've seen how enable and disablement of this actually makes this plug and play, but we actually haven't seen how that plug and play dynamic operates. We need to learn a couple more constructs within feature U before that would make sense. So let's do that now. All right, the second major characteristic that we talked about was feature collaboration. And remember, we broke that down into generalized cross-feature communication, as well as feature-based UI composition that crosses feature boundaries. How does feature U accommodate this? Well, we use something called fassets, or feature assets, to facilitate cross-feature communication. And this is how all cross-feature sharing is accomplished. You can really think of this as the public API of a feature. And the items that you register here are truly open. Typically, there are a function or a React component, but they can truly be anything that you need within your public API. As we will see, this supports both a push and a pull philosophy. We'll see later that the pull side is really required in order to get the dynamics that we want within our plug and play characteristic. So just as a sidebar, we use the term facet, and pronounced F-A-C-E-T, and it's sort of loosely related to that term, but we're using the spelling of feature assets, or fassets. And I should mention that this term is used consistently both in the definition as well as the usage side of the constructs that we're going to be looking at. Well, fassets are introduced through the feature object through, guess what, the fassets property. And this fassets property actually has a couple of different subdirectives. We're going to be looking initially at the define directive. So within a feature, again, for the most part, all the aspects are private implementation details. But for whatever reason within this F1 feature, we have decided that we want to publicly promote our A, B, and C resources. And so that's what I've done here through the define fassets subdirective. I haven't actually shown the full syntax of this, just to suffice to say that A, B, and C is now publicly promoted. Well, because launchApp is in control of the application, it can actually accumulate all these facet definitions, and it promotes a facets object that contains all of them. So here you can see we have the ABC from the F1 feature and the XYZ from the F2 feature. Now you can access the facets object in a variety of different ways. And just suffice to say that it's very easy to get at this object either directly or indirectly. But with this object, we can now do all of our cross-feature communications. So if you have the facets object, you can simply dereference it. Here we're dereferencing the Y resource that's defined in the F2 feature. You can also call the get method, and this allows you to specify a wildcard. So this will return an array or a series of facets that match that wildcard specification. There's also a couple of functions that you can use within your UI composition that provides indirect access to the facets. We'll talk about all of these in just a moment, but the key takeaway from this slide is the facets object allows us to do all of our cross-feature sharing without relying on the import. And again, this is also made possible because feature U is in start of our application, allowing the launchApp to accumulate all these facets appropriately. Okay, let's look at this in some code. Here we are in feature A, feature, and it's defining 3 facets, 1 action and 2 selectors. This is the full-blown syntax here. You can see the items on the right-hand side is how it's dereferenced internally within the feature, and on the left-hand side is how we want to publicly promote it. So you can see that we can actually alias these resources and rename them if we want. We can also use the federated namespace if you so desire. It's really up to you, however you want to do that. Well, that's the definition side. The usage side, presumably from another feature, given the fact that you have the facets object, you simply dereference it. So here we're calling isDeviceReady selector. That's actually defined in the feature A feature. I should mention that this is actually using a push philosophy. So in essence, feature A is simply pushing these resources over the wall. If you wish to use them, they're available for your use. Let's talk about UI composition. So here we are in a common feature, and it's promoting a company logo that happens to be a React component. Albeit a very simple one here. This could obviously be as complex as you need. There's nothing really new on this slide other than the fact that we are actually registering a React component as a resource on this facet. So how do we access this component in other components across feature boundaries? Well, the common way of doing this until recently within React is higher order components. So feature U provides a with facets higher order component, and basically the HOC simply wraps another component and it injects properties into it. So you can see here the with facets, it's specifying which component it wants to wrap, the my component, and it's got a directive of map facets to properties. It's saying I want to map the company.logo to a logo property. So that's how this logo property is defined. And so knowing that this is the logo is a React component, we simply instantiate it in our normal standard JSX syntax. So there is an actual easier way with the advent of React hooks. React hooks was introduced earlier this year. And so basically, this is a simpler example using React hooks. Feature U provides the use facets, and this is a custom React hook. And so within the my component, the very first function, it says, I want to use the facet that matches company logo. That returns that. We hold on to it as a local variable. And again, simply instantiate it with the standard JSX syntax. So I think React hooks is a very popular option, and feature U supports it as of version 2. And so this is a much simpler example of accessing facets within your components across feature boundaries. All right, UI composition can actually be a contract. Now, this is, in my opinion, the most exciting part of feature U. So hopefully I haven't lulled you to sleep, but if I have, this is your wake-up call. A contract is where one feature specifies a series of injection needs, and they are supplied by other features. So this is defined through additional facet directives. Remember, I mentioned that the facets has several subdirectives. Well, it also has the use directive, and that specifies a series of injection needs, and the define use defines a resource under a usage contract. Now, also, these contracts can be represented with wildcards. And as we will see, this provides additional dynamics that allows the content to actually be injected autonomously. And this is a key factor of the dynamics of plug and play. Well, I think these items will make more sense with some code snippets. So let's look at that. Here we are in the main feature. and it's defining under usage contract. Here is the usage contract. It's saying I'm planning on using main page.star.link. So there's where the wildcard comes into play. Multiple resources can match this. Well, anytime you define a usage contract, it's typical for the same feature to fulfill that contract. So here we are in the same main feature in its main page component. And it's saying I want to use facets that match main page.star.link. This is the fulfillment of the contract. We said we're going to use main page.star.link, and here we're actually using it within that feature. So this use facets is going to return an array of resources that match this link. And so we simply hold on to that main links, and then at some point in our render process, we iterate over the links and instantiate each main link individually. Well, that's the usage side of the contract. The definition is coming from other features. So here we are in a new feature, a cart feature, and it's saying I want to specify under usage contract a main page.cart.link. So this actually matches that wildcard contract, and it's supplying its on component. Again, this is a very simple React component. It can obviously be as complex as you need, but it's an internal component within the cart feature that's now being exposed within the main page. Well, again, because wildcards are in use, multiple features can join in on the fun. And so here is yet another feature, the search feature, and it's doing something very similar. It's saying I'm defining under usage contract the main page.search.link with its on component. And so that's going to be pulled into the main page as well because of the usage contract. So this is actually very exciting. We've actually switched now to a pull philosophy, and we're using autonomous injection. Even though the main page component is in control of this process, it really doesn't know about the details of this from a coupling perspective because they are being injected through this usage contract. So let's look at this in our sample code. Previously, we were focused on the sandbox feature, and we saw how enabling it or disabling it caused it to automatically exude the characteristics. Well, that's actually happening through a usage contract. You can see here that its facets is defining under usage contract the app motif.leftNavItem.sandbox feature. Well, I happen to know that this usage contract is coming from the common base UI feature. So if we expand the base UI feature, let's bring up its README file very quickly. As I mentioned earlier, base UI is doing quite a bit, establishing the UI foundation for all of our components. The area that we're interested in here is the app motif. So you can see here that this particular feature is controlling a lot of different things on our screen. It's controlling the left nav menu item, it's controlling the title bar, and it's controlling the user menu entries. Well, even though it's in control of this, again, it's relying on usage contracts to provide the detail here. So if we scroll down and look at the left nav menu, it's saying that it's going to use the app motif.leftNavItem.star usage contract to inject menu items into the left nav menu. And so let's look at the feature object for that. And again, there's a lot going on here, and there's several usage contracts, but the one of interest here is the left nav or app motif left nav menu item.star. And this is the full syntax. You can see you can actually supply validation constraints on this. So any resource that's registered to this can be validated. It must be a React component. It's also saying that's a required resource. So if any of these items are violated, feature U is going to fail fast, which is what you want it to do. So that's pretty cool. All right, the last item I would like to look at is the A-B feature swap. I mentioned this earlier. This is a very common need within feature-based development. It could be that you have, let's say, a new and improved version of a feature, but you only want to promote that feature to a select set of beta testers, as an example. Or as the example that we've already looked at, maybe you want to swap out a real service with a mock service. Well, I don't know if you noticed or not in the list of items or features within eatery-nod, there's a number of services. There's an eatery service, there's a discovery service, there's an authorization service. Basically, in general, services are going to tailor a generalized solution into an app-specific domain. And the end result of that is it greatly simplifies your business logic. Well, you can see here that there is a reoccurring pattern of how these services are implemented. So let's just look at one of them. We'll look at the authorization service. So here you can see that the authorization service is actually promoted through a feature. The auth service feature is going to promote the fact that there is an auth service facet, but it's doing that through a usage contract. So it's validating it to ensure that it conforms to an abstract auth service API, and it's also a required facet. So from a usage perspective, this is all the user needs to know, the developer user needs to know to interact with that, because it knows exactly what the API is, knows how to invoke it, it knows that it's going to exist because it is a default required facet. But the implementation is coming from one of two different features. There is a auth service Firebase, which is the real service, and an auth service mock, which is the mock service. So both of these items are going to use the define use to define this service, and they will have to implement the auth service API because that's something that's being validated. But the key thing to understand here is the enablement of these two features are mutually exclusive. We saw the Wi-Fi usage, and so they must be mutually exclusive because you can't instantiate two facets with the same name. They have to be unique, and it's required, so there has to be one of them that's enabled appropriately. So you can see here that basically feature U is wiring all this up together and doing a lot of validation to ensure that everything is set up correctly. So let's look at this in code. Let's close out all of these. And so I'm going to go into one of the services. Let's look at the authorization service. So within the common area, authorization, the sub-features contain the services. So here are the three features that are related to auth service. So if we look at the auth service feature, you can see that it's defining a usage contract saying there will be an auth service facet, and it's a required resource, and it must conform to a type of auth service API. And here's the function that's actually validating that. So if we did a quick look at auth service API, let's bring that up. This is actually an interface or an object. Let's look at the outline of that object. You can see that it defines some services that we would expect, sign in and sign out, etc. But this is actually an abstract API. It's the closest thing I can get to an abstract API within pure JavaScript. So each one of the methods is actually implemented by throwing an exception, saying that you have to implement this. So you're only going to find out, problems with this at runtime, unlike something that would be able to support a real interface. But you can see here, this is where the validation occurs. So then within the implementation, you can see that, let's look at the Firebase feature. So here is Firebase. It's saying I'm defining under usage contract the auth service facet, and I'm implementing it with a new auth service Firebase. If we look at the auth service Firebase, you can see that it actually extends auth service API, which it must because of the validation constraints. And so the implementation here is the actual call into actual Firebase code. And then if we expand the mock feature, it's doing something very similar. It's defining under usage contract auth service with the auth service mock. We can look at that, but it's basically just the in-memory data source for this particular service. The key thing to note here is the enablement of these two features are mutually exclusive. So here is the real Firebase. It's enabled when our feature flags is using Wi-Fi, and the mock is the opposite of that. So if we're not using Wi-Fi, we will instantiate this particular service. And so all this is really, it's doing all the wiring for you. As an example, let's say we got this enablement wrong, and said we are instantiating it the same way, we're going to get a fail fast from feature U. So because we didn't instantiate any particular resource in this, it's erroring out because it says it's required. And so you can imagine if we got it enabled the wrong way in the opposite direction, it's going to fail because it's saying that there's a duplicate one that was instantiated. And it has to be the auth service API. Let's just put in a 1, 2, 3 here for fun and save that. You're going to get a different error, fail fast from feature U. It's saying it's expecting an object of type auth service API, not the 1, 2, 3. So there's a lot going on here to ensure feature U is ensuring that you have all this wired up correctly. Pretty cool. All right. Well, with that introduction, I think the context diagram of feature U will make more sense. You can see here that launchApp is in control of your application and that it's accepting an input of both features and aspects, and it's interacting with those items through various lifecycle hooks. And it actually is calling back out into the application to domain to do our registration of the root DOM, which makes it compatible with any of the React platforms. And it's also promoting a fassets object, which provides us the ability to do all of our cross-feature communication in an extendable way. All right, before we wrap it up, I'd like to talk about one last thing on feature-based development. We've already mentioned that features should mirror requirements. This is something that really is what makes your code intuitive. These requirements could be either end-user requirements or lower-level system requirements. The second item we really haven't talked about, but that is that features are really a different abstraction from other programming constructs or paradigms. And the reason for that is your code has to implement these other paradigms. So if you've decided that you're going to use functional programming as an example, it's up to your code to implement that, regardless of whether you've organized your project by features or not. So if you really think about it, features are more of a logical packaging with the ultimate goal that they plug and play. So what does this mean in terms of feature U? I've often fielded the question, how does feature U impact my, and then fill in the blank? It could be that you're modeling your components in business logic, or maybe you need the XYZ framework, et cetera, et cetera. I think you can imagine the point I'm getting to here is that feature U doesn't impact you in this regard. What I'm really trying to say is that feature U is non-intrusive. You employ the same constructs and the same styles. You use the same frameworks in the same way. The only difference is your scope is smaller. It's within the scope of a feature. So quite the contrary to being intrusive, the byline of feature U is that it frees you up to focus your attention on the business end of your features. So lest you think I'm becoming a marketeer, I went ahead and added the party popper. And speaking of marketeering, this is the marketing diagram of feature U, and it wouldn't be complete without feature U man. This is basically the same thing as the context diagram. I've just pushed it up a little higher and added some additional graphics. Well, your assignment, should you choose to accept it, is to take a look at the Feature U docs. Toward the end of it, there is a section called Why Feature U. And there I make the case for a number of benefits of using Feature U. So I lay out each one of the benefits, and I also provide some linkage into the user guide that gives you a little more context about each one. So I'd encourage you to take a look at that when you have a chance. All right, well, that's about all I have for today. I'd be more than happy to field questions. You can hit me up at the email address, or my Twitter is available with direct messages. I very much appreciate your time, and I hope you enjoyed the presentation and learned something as well. Thank you.